Hello everyone and welcome to the webinar. I'm going to wait just a few minutes to allow everyone to get in. Okay, let's get started. Thank you for joining today's webinar. The topic for today is creating random test profiles. If you have any questions following the webinar, please don't hesitate to reach out to us. For support questions, you can email support@vibrationresearch.com. For sales questions, please email vrsales@vibrationresearch.com. Now, before I begin, I'd like to introduce you to Vibration Research. VR designs and manufactures vibration control systems and data acquisition systems. Since 1995, it has been the leader in the vibration testing industry. Its controllers are the top choice of testing labs worldwide because of their advanced hardware capabilities, excellent customer support, and powerful user-friendly software. VR is an international company with its headquarters in Jenison, Michigan. Vibration Research's focus is to make the world's most innovative sound and vibration technology tools, enabling our customers to make reliable decisions and trustworthy products. Its core values are collaboration, capable and competent, accountable and responsible, strong and driven work ethic, do the right thing, and innovation. So why do we perform random testing? Well, vibration in the real world is random, meaning it is non-repetitive and non-deterministic. Therefore, random vibration tests are a realistic method of bringing a product to failure. Some applications for random testing include observing product responses, predicting damage for product development, reproducing failures that occur in the field, and creating pass-fail criteria for production or pre-production. If you are interested in the why and how of random vibration testing, we do also have a two-part webinar series on the fundamentals of random vibration theory on our website. So let's jump into creating random test profiles. A random test profile controls our shaker test. To create a random profile, we define a breakpoint table in the software. The breakpoint values determine the distribution of the test power over a range of frequencies. It includes frequency and amplitude values and their crossover slope, and a power spectral density, or a PSD, displays the values we input into the table. So if you look here to the image to the right, this is a random test settings in the vibration view software. Here we have our breakpoint table. You can see the frequency, amplitude, and slope values, as well as the generated PSD from those values. As we run our random vibration test, the software will collect the response on the shaker table and combine it using a spectrum averaging method. The product is a statistical approximation of the random vibration spectrum. Random vibration is generally displayed in the frequency domain as a PSD. We can create a random test profile in several ways. First, we can manually enter the breakpoint table into the software. If we are using a test standard, it will provide the frequency and amplitude values that we need. The vibration view software includes predefined test profiles for the more general test standards, which does save time. We can also use a recording from the field to develop a test profile. This option is advantageous to test facilities that have recorded data and want to create a test profile that is as close to the operational environment as possible. Vibration Research's random import software automatically generates a test profile from a time history file. Here are two examples of breakpoint tables from test standards. The first here is from a ISTA test standard. You can see that it provides frequency and amplitude values, as well as an overall GRMS value and the associated PSD. The one on the right is from an ASTM test standard. We have our frequency values, our overall GRMS values, as well as power spectral density levels for different assurance levels and the associated PSD. For our tutorial today, I'm going to use the values from a typical random test standard. So here I have a breakpoint table from a NavMat standard. It calls for a 6.06 GRMS value overall. Here are my frequency values, my amplitude values, my slope values, and the corresponding PSD profile. Today, we will be using the Vibration View random software. If you would like to download a free demo version of the software, you can do so on our website. I will pause just for a moment to allow anyone who would like to download the software to do so. Now, once we're in our software, we want to first confirm that our control units are correct. I'm going to go to Configuration, Units. Now, in my test standard, my frequency values are in hertz and my amplitude values are in G squared over hertz. This is fairly standard. However, if you need to input different unit values, you can do so here. Next, we want to set up our shaker limits so we know that it is possible to run our random test profile. Again, I'm going to select Configuration, then I'm going to select System Limits. In this dialog, we can enter the limits for our shaker system and the mass of the different elements of our system. The software uses the total mass entries and the limits to determine whether or not our test can be run within the specifications of our shaker system. Now we can define our breakpoint table. To do so, I will select New Test, Random. And today I'm going to be creating an advanced random test. In our table tab, I will start by entering my frequency values. Next, I will enter my known amplitude values. To calculate the unknown amplitude values, I'll first click into my known value, then into the slope value. You can see now that the first amplitude value is highlighted in yellow. When I enter in my slope value, the software will calculate that value. Again, I'll click into my known value, click into the slope, enter the slope. Now we can also paste a breakpoint table from Excel if we don't want to manually enter in the software. To do so, I simply copy the breakpoint table from the Excel sheet, right-click into the software, and select Paste Table from Clipboard. The software will ask me if I want to create an advanced test and also confirm that I want to replace the segments in the table. You can see that our GRMS value is 6.06. If any of these values are highlighted in yellow or in red, that means that the breakpoint table is exceeding your shaker limits, and you will need to adjust your system setup in order to run the test. Next, we are going to schedule our test. In the Schedule tab, we define how long we want to run our test. We can also add test levels and define how long the test will run at each output level. The software supports up to 200 levels, and we can add looping to repeat level sequences. There are also 5 levels for creating and saving reports while the test is running. So here are options in our Schedule tab. If I want to run my test for 2 hours at 100%, I can do so. I could also run my test for perhaps 10 minutes at 50%, then wait for the operator before running my test at 100%. We can also schedule to run the test for an hour, then view a report. And here I would select a report template and then run the test for another hour. Now is a good time to mention that we have a help file in our software. So if you're wondering what any of these schedule items mean, you can select the context button here, click into the dialog, and the help file will appear. Here we have information about each of the level types if you'd like to learn more. Next, we will take a look at the Parameters tab. The test parameters determine how the random control algorithm reacts to the product's response. There are two types of control parameters: startup parameters and running parameters. The starting parameters are applied when the test ramps up to the desired output level. During startup, the controller must be able to quickly equalize the output. The gain value here determines the control's reaction time. The gain should be large enough to reach level in a reasonable time, but also small enough so that the control does not overshoot the intended level. The startup time here defines how long it takes for the controller to reach the maximum output voltage from the threshold voltage. A long startup time is a good precaution because it allows the operator more time to abort the test if the shaker is moving, but the input signals are not registering acceleration. That may occur perhaps if an accelerometer falls off of the shaker table. The running parameters are applied after the test has reached the desired output level. Typically, while the test is running, there will be more averaging and less gain while the test runs because the controller has already equalized the system and only needs to make small adjustments to the drive signal. The averaging DOF, or degrees of freedom, define the statistical factor that the algorithm uses to average frequency data together. The higher the DOF value, the smoother the control line will be, but the controller will display changes in the input signal slower. Now, the general parameters help define the process of PSD averaging. So as we mentioned before, as our random test runs, the controller collects the product response. First, the software moves this time domain data to the frequency domain. Then it calculates the average power of the frequency spectrum. The default values in the general parameters will be acceptable in many cases. Next, let's look at our limits. The limits values define the critical controller limits for a random vibration test. These safety limits will abort the test if the controller detects an inconsistent measurement. The tolerances, aborts, and maximum outliers should provide a reasonable certainty that the test is capable of running. The tolerance lines are shown as dashed brown lines on the graph and determine when the controller should switch from the starting mode to the running mode. If I select the channel tolerances checkbox, I can enter individual channel tolerances. The max outlier percentage parameter defines the maximum percentage of the test bandwidth that can exceed the abort lines before the test shuts down. So as we are running a random test, an occasional line outside the abort values is typically allowed, but many lines exceeding the abort limits indicate that there's some sort of problem. The RMS parameters define the maximum and minimum RMS acceleration level for the control channels. If we go to our startup drive limits, the output threshold and starting max system gain parameters are safety limits that define the output voltage limit. When an accelerometer is connected to our controller, the output voltage increases as the measured RMS acceleration level from the accelerometer increases. The running max system gain parameter limits the output voltage as a function of the measured RMS acceleration while the test is running. The max output parameter defines the maximum RMS output voltage. If the drive signal exceeds this value, the test will abort. The Start with Projected Levels checkbox displays a projected levels window as the test starts up, which shows the projected levels that will be required at full level testing. Next, we'll go to our Channels tab. Here we can define the input channels in the random control loop. An input channel is any device that is connected to the controller's input connectors, and this may include accelerometers, microphones, external conditioners. If we select multiple channels as a control channel, the controller will combine them with averaging using maximum or minimum values, and we can select that option here in the drop-down. A control channel is any input that we want to keep within certain tolerances. So if we have an accelerometer on our shaker table, as well as on our device under test, and we want to ensure that the vibration at both locations does not exceed certain values, we want to control those channels. So both of those items would be a control channel. In our Data tab, we can determine how we want to save our test data. We can save data at the end of a test level, at the end of the test, at the end of a sweep, or at a regular time interval. So here we have our Save Data to Disk section where we can select how often we want to save our data. Our data is going to default saved into a storage directory. We can change that. We can also select where our reports are going to be saved. Remember, we did schedule some of our reports here in the Schedule tab. So here in the Data tab, we'll determine where we're saving those reports. There are several other considerations that you may want to look into that are more advanced than the scope of this webinar. The Vibration View software is capable of notching, which is a technique that technicians can use to limit vibration levels at various frequencies during testing. Random import is a feature of the random software that generates a random test profile from recorded data. The fatigue damage spectrum is a test development tool that replicates the operational environment of a product. And finally, kurtosis control is a method that may be necessary to add high peak accelerations into your test. If you have any additional questions about generating a random test profile, please do not hesitate to reach out to us. Thank you very much for attending the webinar. Have a great afternoon.